Here is the answer key to the activity Dilations in the coordinate plane. When you drew your figure 1, you should have ended up with something that looks like this. Now it's going to be important for our chart for us to understand the dimensions of this figure. So if we are talking how wide he is, or she, however you want to think about it, is 12 units wide. And our figure is going to be 8 units tall. And those are going to be some dimensions we are going to use over and over and over again. So either you or someone you partnered with drew figure 2, and so here I have a picture of my figure 2. In this box, you and your partner should have decided, do you think that looks similar? Is this figure, figure 2, similar to figure 1 just by looking at it? So that was a yes, no. All right, and then if we look at our coordinates, let's go ahead and go down to a general rule. I think my spacing might be off on my table a bit, so my parentheses are off. You'll have to excuse that. But if I compare my coordinates from figure 2 to my coordinates on figure 1, you will notice that figure 2, the x coordinates are 2 times larger. Oh, that's an x. And your y coordinates are 2 times larger. So if I wanted to compare, I'm down to the next box. If I wanted to compare the corresponding sides with the original to determine if they are in proportion, here's how I would do it. So my widest side, notice I already have the 12 from figure 1, compared to the tallest side on figure 1 was 8. I want to know, is that in proportion to this figure 2 side? And so if I were to count its widest side, this side right here, I would find out that figure 2 is 24. So I'm going to put a 24 right here. And if I wanted to count how tall figure 2 was, figure 2 is going to be 16. And so let's think back to our proportion work. Whenever we have a proportion, if it is equivalent, I should be able to cross multiply. I should be able to take 12 times 16 and get a number, and take 8 times 24 and get a number. And if those numbers are the same number, those ratios are in proportion. And it so happens that these are equal. And so you're going to look at your prediction, and it looks like two things are happening here. I have the same scale factor as my multiplier. My sides are in proportion. So this is a similar figure. Yes, it is similar. So in this box right here, I want you to check your prediction from the very first top green box. Were you correct or incorrect? All right, here is my picture of figure 3. When you and your partner work together, you should have made your prediction. Does this figure look similar to our original figure? All right, so we're going to focus on our ordered pairs. If you compared the ordered pairs from figure 1 to figure 3, you would notice that the x-coordinate got 3 times bigger, but the y-coordinate stayed the same. So our general rule is we're going to triple the x-coordinate and we're going to leave the y-coordinate the same. Now just eyeballing my figure, it certainly looks like it's been stretched, sort of like silly putty, 3 times wider but got no taller. All right, we are ready to compare our corresponding sides. Now notice I already have, whoops, and my arrow needs to go over there. I already have my figure 1 numbers. It was 12 wide and 8 tall. So if I look at this figure and I want to know how wide it is, I would simply count. And this one is 36 wide. And if I want to know how tall it was, you could just count that out, and that's going to be 8. All right, so I'm going to do my cross multiplying to see if these proportion, or if this makes a proportion. Are my ratios equal? So I would take 12 times 8 and I'd get a number. I'd take 8 times 36 and I'd get a number. And I'd compare those two numbers. Did you get the same number or not? Well, I got different numbers. Those were not equal to each other. And so there are really two things that you need for a similar figure. You need the same scale factor or multiplier, and I'm not sure we have that. I'm multiplying x times 3, but I'm multiplying y by 1 in essence, so that doesn't work. And the sides are not in proportion. This is, that's an n. This is not a similar figure. So you can check your prediction. Were you correct? All right, here is my figure 4. You and your partner made your prediction. All right, so let's compare the ordered pairs from figure 1 to figure 4. And it looks like my x-coordinate, let me change my color. My x-coordinate was 3 times, let me get rid of this, 3 times wider, and my y-coordinate was 3 times bigger as well, so that makes it 3 times taller. I'm next going to check my dimensions. Notice that I've got my figure 1 dimensions already there, so I just have to count. This figure is 36 wide, and it is 24 tall. So I'm going to check this proportion. I'm going to use cross multiplication. 12 times 24 will give me a number. 8 times 36 will give me a number. And those two numbers are actually the same. So we're going to check our predictions. You decided whether you thought that was similar to the original figure, and we need two things for it to be similar. We need the same scale factor used as our multiplier, so we have 3 times wider and 3 times taller. And we need the sides to be in proportion. So check your prediction, and this one, yes, it is similar. All right, you should already have your prediction made. So let's move on to our ordered pairs. So you are comparing the ordered pairs from figure 1 to the ordered pairs for figure 5. And you should find out that the x-coordinate did not change. The y-coordinate was 3 times bigger. So if you look at my figure, it does indeed look like it's just as wide as it was before, but I've stretched it 3 times taller than it used to be. All right, let's compare our corresponding sides. I already have figure 1 put in. So if I count this guy up, he is 12 wide, and he is 24 tall. I'm going to check this proportion using cross products. So 12 times 24 will give me a number. 12 times 8 will give me another number. And I don't even have to check those. Those are not going to be equal to each other. So for this figure to be similar, there are two things that need to happen. I need to have the same scale factor used as a multiplier. Right now I have 1 times x and 3 times y. That is not the same multiplier. In addition, I need the sides to be in proportion. This is not a similar figure, so go ahead and check your prediction right here. All right, so here is my figure number 6. You and your partner should have already made your prediction about whether it appears that this is a similar figure or not. Let's go right into our ordered pairs. So the ordered pairs for figure 1 compared to the ordered pairs on figure 6 show us something different is happening. The ordered pair, the x-coordinate from figure 1, you have to add to get the x-coordinate for figure 6. The y-coordinate from figure 1 has to have 2 added to it to get the y-coordinate for figure 6. These are addition problems. Let's see what happens with those. All right, so we're ready to compare. I already have our figure 1 coordinates right there. If I were to count this guy, he would be 12 wide, and he would be 8 tall, and I don't even need a calculator for that. I know that those are equal. Now keep in mind there were 2 things that we need to have similar figures. We need the same multiplier or scale factor, and we need this to be equal. So let's just look up here for a second. There is an invisible coefficient or multiplier of 1 before each of those letters. So technically, I have the same scale factor, and the sides are in proportion. So yes, this guy is similar, but he's more than that. Because my scale factor is a 1, he's actually congruent. If you look at figure 1 compared to figure 6, exactly the same size and shape, but there is a difference, and it has to do with this add 2 and this add 2. It's a location. So think back to when we were doing translations, rotations, and reflections. What has happened in figure 6 is that he's been translated. He's been translated 2 to the right. That was the x plus 2. And 2 up, that was the y plus 2. So although he is similar, he is also congruent. All right, we're down to the last 2 questions. So what are the 2 ways to determine if a dilated shape is similar to the original? Well, 1, we have to have the same scale factor. Your scale factor can be thought of as your multiplier. It could also be thought of as maybe a coefficient. You might also see it as the letter K. The other thing we need is that corresponding, I'm going to abbreviate, corresponding sides have to be in proportion. If they are not in proportion, you do not have a similar figure. So you must have these 2 things. There's a big and in here for you to have a similar figure. Okay, the last question says, what would be the effect of multiplying each of the coordinates in figure 1 by 1/2? Now, I did not ask you to draw this out, but some visual learners might need to see this in order to double check what they're thinking. And so I multiplied everything by 1/2. Remember, I need 2 things to be in effect. I need the same scale factor. And so my x-coordinate was half what it used to be, and my y-coordinate is half what it used to be. My scale factor, my multiplier, my coefficient, my k, whatever you want to call that, is the same. My original, remember, was 12 wide and 8 tall. This one is 6 wide and 4 tall. So if I checked my sides, they would be in proportion. So one effect is that I'm going to get a similar figure. Let me change my color on that. Hold on just a second. All right, so I have a similar figure. The other effect is that my new shape is going to be half as wide and half as tall as the original. Now, in our next lesson, we're going to see how perimeter and area are affected when you dilate a figure.